Okay, in this video, we're going to take a look at a few key calculations for acids and bases. Now, this is for strong acids and bases. What we're going to do later on is weak acids and bases. What you should make notes on in this unit are the three types of acids and bases. Anious, Bronsted, Lowry, and Lewis. So go through and make sure you've got good notes on what those are and how you look at an acid or base and tell which type of acid or base it is. We're going to go through our Anious acids and bases a little bit just because we're going to need them to do some of the calculations. So Anious would say an acid is something that decomposes to release, believe it or not, that says release, H plus in solution. Now you'll see two different symbols there. You'll see H plus or you'll see H2o plus or hydronium in solution. Bases decompose to release OH in solution, which is called hydroxide. Now if you notice, if you take the H and the OH, what do you have? You've got water. You've got H2O. So this is going to be very important, what I'm about to do. H2O breaks down. So water is a liquid and it breaks down. 1 times 10 to the negative 7 ions of H plus and OH negative are formed in 1 liter of water. Now that's very little of the water that breaks down, but water is in an equilibrium. So a very, very small portion of water is breaking down into H plus and OH negative ions, and then they reform into water. Now there is a constant for water, and it's 1 times 10 to the negative 14, which would be 1 times 10 to the negative 7 H plus ions times 1 times 10 to the negative 7 OH negative ions. Those numbers, 7 and 14, are going to become very important when we look at something called the pH table. 7, neutral, equal amounts of acid and base, 1 times 10 to the negative 7 and 1 times 10 to the negative 7. The kW of water to the negative 14, there's that 14 in the pH scale. We're going to come back to that. Here's the important part. Water's always in balance with a kW of 1 times 10 to the negative 14. If we add an acid to the water, what's going to happen is we're going to upset this balance. So if we add 0.001 molar acid to the water, we can find out what our OH is going to be. So all you do, if you add an acid or a base, so if you add an acid to water, put the number in here. If you add a base to water, put it in here. To find our OH, we're going to take that 1 times 10 to the negative 14 and we're going to divide it by 0.001, or the strength of the acid. And our answer is 1 times 10 to the negative 11. Now, we said our OH is usually 1 times 10 to the negative 7, and our H is usually 1 times 10 to the negative 7. But if we add an acid in, that's going to upset this balance. These two numbers always have to multiply out to give 1 times 10 to the negative 14. So if they give you an acid or a base and ask you for the opposite, divide the 1 times 10 to the negative 14 by what they give you. Let's try a problem. 4 grams of NaOH is added to 200 mils of water. What is the pH? Well, first of all, we need the concentration, which is moles over volume. Our volume is 200 mils, which is 0.2 liters. Our moles is equal to the 4 grams. The molar mass of NaOH is 23 plus 16 plus 1 is 40, is 0.1. So what we have is 0.1 divided by 0.2, and that's going to equal 0.5. That's our concentration. Folks, I'm going to do something here. I'm going to change this and I'm going to call it 0.4 grams and make that 0.01. And this 0.05. There's a reason I'm doing that mathematically. but all I did was I changed my initial amount of NaOH to 0.4 grams. So my concentration right now of my base is 0.05. So if my base is 0.05, what is my acid or my H plus? So I take 1 exponent, negative 14, I divide it by 0.05, and I get 2 times 10 to the negative 13. Now what I can do is I can find the pH of the solution. Once I have my H plus, you can find the pH of the solution. All you do is hit or put in 2 exponent negative 13 and then find your log button on your calculator. So I have to go and I will get an answer of negative 12.7. Hey folks, figure out how to use your log button. All I did was I put 2 times 10 to the negative 13 in and I hit log. It gives me a negative answer. Always, this negative out front here means you're always making this positive. So if you get a negative answer, which you always will, make it positive. 12.7 is the pH. This makes sense because we have a base. So that's our pH. Folks, if they ever give you a pH and they want you to get the concentration, all you do is you find the second function of that. Now, every calculator is different, but what you want is you want the opposite of the log. So you want the 10 to the x button. So I have found that. Then I'm going to put in my number, which is 12.7, but you got to put in negative 12.7 for this to work. I will get there. Okay, folks, you've got a couple things you've got to keep straight here. You always need a concentration to put in here. So when they gave me all of this information here, I did the hardest type of question I could do and I got my concentration of H+. Then I take the log of that concentration. It will give you a negative number, make it positive. If you want to do the opposite, if you want to change the pH back into a concentration, concentration equals 10 to the minus pH. So what you do is you hit the second function of your log buttons to do this. And you will come up with an answer that looks like this one up here. So they can have you go both ways. This is the formula that's used the most. pH equals the negative log of the concentration. Let's take a quick look at the pH scale. The pH scale goes from 1 to 14. Mathematically, there's a reason it starts at 1 and not 0. That's because what the pH scale does is it counts decimal places. So the 1 means 1 decimal place back in concentration. A pH of 7 would mean the concentration of hydronium or hydroxide, is 1, 2, 3, 4, 5, 6, 7. So it's 0.000001. That's 7 decimal places back. 1 to 7 is acidic. The closer you get to 1, the stronger you are. The closer you get to 14, the stronger you are. Look at characteristics of acids and bases and put them on a scale. Make sure you have that in front of you. You will notice that both acids and bases are very corrosive, and the further you get to the ends, the more corrosive it is. Now, we use things in the lab all the time that are way off the pH scale. Like the pH scale was only made for common items like apple juice and vinegar. But I have acids that are hundreds of times off this pH scale that we use all the time. So just remember that this is just a common scale here. Things you should be able to do. If you're given the concentration of a base or an acid, you should be able to use this formula here to find the other. Once you've got your H plus value, you can take the log of that and you can get a pH. So once you get the concentration of the acid, you can get the pH. If you're given a pH, you should be able to work backwards and get a concentration. Make sure that you go over the different types of acids and bases.